Alright, so on page 44, if you are going to start looking at complex numbers, so welcome to extension 2. So I hope the journey, while it will be tough going and hard work at times, or most of the time anyway, I hope you will find it very interesting and very beneficial, obviously, when you finish the course, and how it's going to prepare you for further maths that you're looking like both doing at university based on the degrees that you've indicated that you wanted to do. Alright, so throughout history, different number systems were developed according to discovery of different types of numbers. So let's take the quadratic equation. So x squared plus 1 is equal to 0. So when we're solving for that quadratic, we will have to move the 1 over to the negative side, so it becomes x squared equals negative 1. Okay, so as it currently stands, we have no real solution because we cannot take the square root of a negative number. However, now it's pronounced Euler, okay, like oil, developed a way to have solutions of no solution equation. So what he suggested is to write the square root of negative 1 as I. Okay, so whenever you see the I, it equals the square root of negative 1. Okay, and using your third laws, we will be able to extend from that. Okay, so squaring both sides. Okay, so I squared is going to be negative 1. Okay, so I times I, negative 1. So for the above equation, so we have x squared equals negative 1. So we take the positive and the negative square root of negative 1 to solve for x. Okay, and of course we had there plus or minus I as our solution when we introduce the new number system. So there's a diagram labelling the different number systems in relation to each other. Okay, so we've already talked about the real, irrational, rational integers and natural integers. Okay, so the real numbers, so all the numbers that exist in our natural number system, okay, are what's called real numbers. Now from real numbers we have the irrational numbers, okay, so where we cannot write that as a fraction a over b, where a and b are integers and b is not equal to 0. We also have rational numbers, so we can write them as a fraction as a over b, so we can have decimals, fractions obviously there as well. Things that we can write as a over b, where a and b are integers and we of course cannot divide by 0. Okay, now the set of z numbers, okay, so the set's called z, they're defining the integers, they are the whole numbers, okay, so where the denominator is 1 for the fraction a over b. And then we have, from the integers set, we have a smaller set of numbers, which is the natural integers, okay, so where we have positive whole numbers, okay. Now you'll, just to let you know, that definition is not consistent, because some have it greater than or equal to 0, okay, so they're defining 0 as also a natural integer, okay. With the diagram, I don't think 0 is included in the natural integers because that's what's defining your positive and negative numbers. Okay, but just be mindful that it can also have a definition which is greater than or equal to 0. Okay, so numbers that are not part of the real number system are what called complex numbers, and that's what we'll be looking at a fair bit in this topic. So there's a diagram just outlining the set of the real numbers there. So a single polynomial z is used to define a complex number. So complex number z equals x plus yi. So we have two parts to a complex number. We have the real part, okay, so that's the real part of z. Okay, it's a number that is part of your real number system. Okay, and then you've got the y part, the part with I in it, that is your imaginary part of the complex number. Okay, Now, keep in mind, y is real, just y is real, but because it has I with it as well, it makes it a complex, okay? So it's not yi is imaginary, it's just the y that's imaginary, okay? To do that. So, examples. So what are the real and imaginary parts for the following complex numbers? So, Z, 4 plus 3i. So we need the real part and the imaginary part. So, what's the real part? 4. What's the imaginary part?
3.
Just 3. Okay. So without the I with it, it's obviously the imaginary part is the part of the complex number that has I with it, but when we say the imaginary part, we will always say the real number part of it, okay? Back.
Sembra che mi hanno concept.
This doesn't seem too bad. Just yet.
Can look at the pages. I don't want to. Don't think of modulus argument form of a complex number.
B. So Z is equal to negative 7i. So, what is the real part?
0.
Good. So the real part is 0, and the imaginary part is?
-7.
Okay, just the real number component of it. Don't put negative 7i, put the real part. Good. Right, question?